Okay, I think we'll be okay with just one example on this, to be honest, because we've done quite a lot of work building up to it. So approximating the binomial with the normal. It's the only approximation you have to do in maths. In further, I think we need to do a bit more than that. So we've got a particular type of flower bulb, 55% will produce yellow flowers, and a random sample of 8 bulbs is planted. We want the probability that less than 4 will produce yellow flowers. So you need to think about, is this a binomial or is this a normal distribution question? So we've got a fixed number of trials n. We've got 2 possible outcomes. It's either going to be a yellow flower or it isn't. And the outcomes are independent. So fixed probability of success. Can't think of anything else. It's a binomial distribution. It doesn't hurt to define your random variable. So let x be, remember it's always number of, however you're defining x. So number of yellow flowers. And then x has a binomial distribution. N is 8, and the probability of success, which is the probability of getting a yellow flower, so they match, is 0.55, and we want the probability that x is less than 4. Remember for the binomial that your calculator gives you cumulative probabilities, so it'll give you less than or equal to probabilities. And then go to your calculator, our favourite menu button at the moment, so menu 7. You'll have to scroll down to get to binomial CD. So that's option 1. Well, after you scroll down, you just need one value, so it's variable. So x is 3, n is 8, and p is 0.55. And so we get 0.260. So 26% of the time you're going to get 3 or less yellow flowers. I was just about to say something else, but it's gone. It'll come back to me in a minute. So next bit, we want to write down 2 conditions. Oh yeah, the other thing, you wouldn't really approximate this one with the normal because n is too small. That's what I was thinking. Right, write down 2 conditions under which the normal distribution may be used as an approximation to the binomial distribution. So the 2 things you're expected to write for A-level maths, there's different ways of doing this. If you look them up, you can use n times p and n times the variance and make sure they're both over 10. But anyway, for A-level maths, the 2 conditions you're looking for is n large. And if it is one of these, it's going to be quite large, it's going to be quite obvious. And p close to 0.5. And then you get a good approximation. So as a rough rule of thumb, I'd say n bigger than 20 and p close to 0.5, so definitely between 0.4 and 0.6, if not a bit closer than that. If it's an approximation question on an exam question, it will just be quite close to 0.5, so don't worry, and n will be quite big. So a second sample of 300 bulbs is planted. Using a suitable approximation, find the probability that more than 200 have yellow flowers. So x can still be the number that have yellow flowers. X is binomial. N is now large, and p is close to 0.5. So it's fine to use a normal approximation. And we want the probability that x is bigger than, oh sorry, I changed this and I forgot. Can we change that to 180, please? Just get a slightly better value coming out, otherwise it's tiny. And so you approximate all of this with x being normally distributed. The mean of the binomial is np. So you do 300 times 0.55, 300 times 0.55, and that gives you 165. So that's your expectation on the binomial, which is the same as the mean. And then the variance is NPQ, or NP times 1 minus P. So I need to times that by 1 minus 0.55. So that's 0.45, which gives me 74.25. So just to make that doubly clear, that bit there is NP, and that bit there is NP times 1 minus P, and that gives you the variance in a binomial distribution. And then you need to make the continuity correction or it will be wrong. So in a normal distribution, if x is bigger than 180 in the binomial, then x is greater than or equal to 181. So use that if it helps. So we would need x to be bigger than 180.5. And then you can just whack that through your calculator. So I'm back to menu 7. I want normal cumulative. My lower value is 180.5. Upper value just needs to be something pretty big. 1,000 would be plenty. I've got 10,000 there. Just be careful on the standard deviation. This is the variance, so you need to square root the variance to get to the standard deviation. So it's the square root of 74.25. That's just a really easy thing to forget. And the mean is 165. And you get 0.0360. And it is as straightforward as that. You could probably put that into the binomial and just check that they're quite similar. But don't forget the continuity correction. And that's it for those. So you should be good to do a few of those now. And then we'll finish off the hypotheses testing next lesson.